Guys, welcome back to the room. Good morning to those watching us online. This GitHub seminar will be presented by Joe, and it will comprise two parts that will be broadcast. The first part addresses more theoretical aspects, and Joe will present them using a set of slides, and then he will show some practical aspects of code management using GitHub in the second part of his presentation. And then the broadcast will end. And after that, we will still have some further exercises for those in the room that may wish to practice. So, Joe, thank you very much for having accepted to present. And here's the microphone. The stage is yours.
Thank you. Yes, thank you. Thank you, Professor, for giving me the opportunity to share my understanding on code management and to present it with GitHub. So today, my presentation is about code management with GitHub. Our content involved in 4 sections. First, motivation. Second, terminology. And then ideology and practice. First, motivation. So the motivation also consists in 3 parts: process control, supervision, and teamwork. Process control. So in the development process, when we code or when we design, we would like to mark down each milestone of our designing. And just in case in the future there's some confusion going up, we would like to go back in time and see what has been done at a certain point of time. And just in case anything goes wrong, we would like to go back to that certain point and continue the development and adjust whatever that's been wrong. And in project management, also the traceability of your coding or your design is also very important. When you design a piece of code, you would really like to know what kind of course or what kind of task this piece of code belongs to. So code management also allows you to get involved in that aspect. Supervision. In a team, in a company, supervision of your code, of your design is rather important. We would really like to control over what we have done of our product, of our design. So first of all, when I assume in a company there won't be only one developer, or possibly there will be many developers. And some of the times people make mistakes and the code are not always reliable. So we would like to take a review of the code that other people have been doing and manage it and take the control of making it our release version. So when a developer have raised up a solution, he might think this is the solution that have solved the problem. But there might be more optimal solution, better solutions that can be formed in order to solve the problem better, faster, with better performance, or even better with future planning or for more advanced functionalities. When a programmer or when a developer is doing their design, doing their work, some of the requirements might be missed, and the requirement might not be met. So in the end, when all the code or all your design have been merged, integrated together, and you're ready to hand out the product, then you talk to the customer. The customer won't be happy about your design. Then you have to go back to do all the work again. That's the thing that we want to handle. So so by doing code management, we can eliminate that or limit that possibility as less as possible. I'm sure for our students or for beginners, we would tend to program a piece of code that's specifically for one requirement, one task, and those codes or those designs are not really reusable. It's mainly focused on one course of problem and not focusing on more parts. That's why we have object-oriented programming. We would like to reuse the code and to make our product more neat, to give a better quality of the product. I'm sure that we are going to have a teamwork of effort to make development. So from team member to team member, we have different designs, and it's really hard to cooperate within the team because everyone have their own mindset, and is in the end when we try to integrate the code together, there might be some part that's off, and so then we will put more effort to integrate with the code. Design are also hard to be united. This includes coding style, this including formatting, and this includes interfaces of your code. So with code management, you can define and share your definition of code to everyone into your team, so that everyone follows the same standard, and we also have more control of the code of your team member is doing, so that they are following the same format. Duplication of the work might jeopardize the product quality. So when one developer is doing a functionality, they can tend to have a piece of code doing exactly the same functionality as the other person to serve different purposes. But in reality, we can literally reuse this piece of code. And as this piece of code is divided between two persons, they might have different performance. And when those different performance have been integrated into your main product, different functionality tend to have different kind of performance. That's something we don't really want, because we want the customer to be satisfied of our product. And coding in the same section can really ruin the functionality. So let's say two developers are doing the same functionality at the same time. When they are committing the code, or when they are integrating the code together, the order really matters. If the order is off, I'm sure in your career or from your experience, there's one or many occasions where the order is really off, and just one line off, and your functionality just doesn't meet as you expected. So with code management, you can actually monitor it beforehand instead of doing it in the end, in the integration point, where massive code have to be reviewed. So terminology, we will divide this into areas, activity, and communications. The areas is organization, repository, branches. Organization, we can consider our whole class as a organization, or just a whole development team or the development department as a whole organization. Within this organization, we can have many products. From my point of view, different product with different service can be within different repositories. These are the areas for your development. For instance, we can have Microsoft Office as the organization, and each repository can be either PowerPoint, Word, and etc. Also, the repository can be divided as front end, back end, and the service section of the code. Then in the end, we can have the integration together so that the order is well recognized. Branches. Branches is the branch is the development line of the line of development of your repository of your product. Let's say we have a Microsoft Office PowerPoint 2015 version. That would be one branch. So when we're developing on that product, you don't really want to the developers to develop directly onto the main branch, because that might jeopardize the overall quality or the functionality of the main product, the release product. You want to have a separate line for development, and after testing, and when the test is okay, then you get it integrated into the main branch, so that your product is under control, and you won't really risk that much for your product quality. So branches are very important in our case, since different person are going to develop on different branches. Activities. So when you develop, you have a piece of code, and you really want to make that public. You want to make this a milestone or a point that's really significant. That's called commit point. And by doing that, you're doing commit. As you can see in this picture, you have several dots on the branch or on the development line, and each dot is a commit point. Theoretically, you would like to have commit points as much as possible, so that when you go back in time and take a look at your previous code, your previous design, your design process, then you can go into very detail and to manage each functionality or each detailed functionality in a very specific manner. Push and pull. Push and pull is to making your code from your local and from to the public, so that or making the code in the public, put it back into your local machine so that you can start development. Pushing and pull can be also summarized as synchronizing. So when you have a code on your local, you do a push so that everyone else can take a look at your code. And when there's a official code online that is available for you, you can do a pull to go back to your local, so that you can start developing on new functionalities. Merge. So as I said before, that when you are on a development process, you have a main branch, you have a main product, and you are on different development line. And in the end, when your main functionality is finished on that different line, you would like to do a merge into the main branch so that you can make the functionality official. So at some point, you will make a mistake, trust me. So that's the importance for the commit points. When you make a mistake and you don't really want this mistake to be existing in your main product, you can do a revert that is going from one commit point back in time and remove one of the commit. That's also the important why having as much commit point as possible is important, because when you are reverting, you can just simply revert that specific code and remove it from your main product. The rest of the product will be maintained as the same as we have developed, so that you don't have to continue to develop everything all over again. Reset. Also, reset is something that you mostly do locally. That is when you have developed some piece of code and you've realized that this piece of code is not actually useful, or is not actually the product that you would like to hand out. So instead of removing everything line by line, you can just simply do a reset. That is resetting your local code, your local saving into the official commits that you had before. Communications. So when you are on a development process and you want to merge your code in your local development branch into the main branch, you would like to do a pull request. It's really rare that as a developer ourselves, we will merge the code by ourselves to the main branch. Most likely, you will create a pull request for your supervisor, or in our case, in the project management, the team leader to do the pull request for you, so that they can take a review of the code and see if there's something wrong, if there's something not clear, or if he or she want to have more functionality, more detail added into your code. While doing pull requests, while doing code review, you comment on the piece of code that you have of what you are not clear about, some new suggestion, or simply you have to request for changes if the functionality is not met, or there's a format that's really off. In the end, when everything is in line, you and yourself agree with the team leader, then the pull request can be approved. So doing the communication is really important for supervising, for controlling your product. That is integrating everything we have said before together. So ideology, product control. As I have already mentioned a bit before, as I have mentioned a bit before, we will have a main process of a main branch that we would like to have our product in. So let's consider this a main branch. Well, I hope it's okay. I use the example of Microsoft PowerPoint 2015 version. I will call it version 1. So I have a development line of the main product of version 1. And I would like, let's say, to introduce a functionality of having the enabling video recording on PowerPoint. So instead of developing on the main line, which might jeopardize the quality or even the main functionality of the main product, I create a new branch and call it function 1. In our case, can be video recording or anything. And I start my development on each point. In the meantime, someone else might develop on another functionality. Let's call it function 2. So he or she will do some functionality, and then in the end, when we think that we are finished with the coding, with the designing, we will make pull request. Let's say the other person is doing a better job. He have agreed with the team leader in the first place, so his branch is merged into the main branch and made it official. And yours, you have to do some more work because there are some functionality that your team leader is not happy about, or the format is a bit off. So you make more commits and push it on to update your pull request. And then at this point, what happens is that as this branch is merged into the main branch, and your branch is origin from a previous point of the main product, the functionality on your branch is back in time. So what if the first thing you want to do is to merge from the main product and then continue the pull request. At this point, maybe you agreed with your team leader and the pull request is merged. That way, we will avoid conflict between codes. And also, doing the pull request is really controlling of your product, your coding style, and can potentially increase the readability for future development. So at a certain point, you would really like to release your product and having an end of the development of this product and maybe have a version 2. So the version 2 is usually another branch. We don't really want to cut this point and use this section as version 1, this section as version 2, because when we go back in time, when we want to look at what we have in the previous product, we don't really want to go through all the commits, although it's really important. We don't really want to go through all the commit and find a certain point of release. What we really like to do is to branch out directly from version 1 and into version 2, so that this is another main line of development and can be released at a certain point individually, independent from version 1, and also you can do more branch out, more functionality from version 2. Now it comes into the design control. As a developer yourself, when you are designing, you are actually interacting with 3 parts. As we have shown in the PowerPoint, at the top, we have the online code or the public code. I would just call it online. And then you have something I would call the local remote. So the local remote. So this piece of code is stored online. This piece of code will be on your local machine. And when you are doing your development, you will have your local code. When you're doing your design in your local code, you save, you do adjustment, you review, and then you do commit so that it make it official for the local remote. And when in the end, when you feel like it, you can push it to online. And if there's something new online, you pull from online, and these two parts are usually called synchronizing. Yeah. So this is the part for design control. And also we have the relationship with the project management. So in the project management team, I'm sure we are already fairly familiar with that. We have a team leader. We will have the chief technical officer, and we have the development team or team member. So the structure will be like this. We have the CTO on the top, and the CTO will be answered by several team leader. Each team leader are leading several team member. When doing code review, when reviewing the pull request, is the team leader that is handling the responsibility of controlling the product and the quality of the code. So when a pull request be made by the team member, it will go directly to the team leader, and you have a direct communication between the team leader and the team member. And when the code is official, the team leader will be responsible for whatever code that he or she reviewed and merged into the main branch. On the traceability wise, when we are doing commit to the main branch, we would really like to mention the user story or the task number inside of the project management into our commit, so that in the future, when we go back in time or when we review our design, we know each commit that belongs to each task. That also is very important for history tracking. And also version control, as I have demonstrated before, that you have one version for each branch to control the version. And with this team structure, you can really make that happen. Yeah. So this is so much for the introduction and the ideology. Now I would like to demonstrate a little bit on a tool called GitHub. There are many tools online that can help you with the code management, but personally, I really like to use GitHub. I tried to use several other things before, but so far as I know, GitHub is really good at this code management. So when go into GitHub, and you will see that in this case, our USM Master Embedded System 2018 is an organization. Under this organization, there will be several repositories, and our course here from Professor Jose is the hardware-software co-design. When I go inside of this this repository, you see the first you will see this user interface with branch here, and here is listed all the branches that you have. Of course, all the open branch, and you can also close branches, but I'm not gonna go into detail on that. So usually the default branch will be the master branch, but as we don't want to have the development only the main product only on one line, I usually don't recommend to use the master branch. Instead, we'll have another branch. Let's say this VHDL review is our main branch, or we can call it version 1, as our first segment is called VHDL review. And this is the main branch. There's a tool called GitHub Desktop. I've introduced it to you. I have introduced it to you before, but I would like to reintroduce it again. So when you want a repository, when you want to copy a repository from GitHub, you really like to clone the repository to your local. As I would like to clone the repository of hardware software co-design to my local, and there you go. The current branch is master. As I said, we're not going to use master. We're going to use VHDL review, which is our first version. And when I open the Explorer, you can see that the VHDL code is there. When I go back to the master, it's simply gone. So, so this is a very good tool for us to switch between different development line, as it doesn't require us to copy and paste and doing backup by ourselves. Just do it automatically with the tool. So let's say now I would like to develop a new functionality. I don't really want to, as I said, I don't really want to develop directly into this branch. This is our release. I would like to create a new branch that is based on our release, and I will call it Bozhao function 1. Well, this usually you should have a better naming of your functionality or the tasks that you're going on, but since we don't really have a very specific content, I will just call it function 1. I create it. And now when I change, do whatever change that is here, it doesn't affect our main branch. So when I'm doing the changes here, let's say I'm doing development. At a certain point, I am going to, let's say I want to change something in this section, but instead I changed something in this section. Say the run function. When I save and close, you can see the changes are being demonstrated inside of the user interface of GitHub. Here, I will write a message about the commit that I'm about to do. So usually, you will link to your task number. Let's say user story or task number 15. I say I did a run function. I commit it. And then I will push it. In this case, we can see it's called publish this branch to online. After I publish it, I would like to ask my team leader to merge it. So I will create a pull request. This will direct us directly into GitHub webpage. And be careful of your base branch. You should use a base branch as the branch that you are going to do merge in, which is, in our case, VHDL review. I will create the pull request. And Professor Jose, can you please kindly act as a team leader to help me do the code review? But in this case, please merge directly without reviewing. Let's make a mistake first, so that we can see more features from GitHub.
Yeah, and I, of course, without looking, confirmed that everything was correct.
So in this case, the team leader have done a bad job, of course, by not taking a look at what the file changed. If he have taken a look, he'll see that this is the wrong functionality. But however, in the future, when we're testing it, we find out this is actually the wrong functionality. So what we can do here is go back into our main branch, fetch the origin, that is putting it back, view the history. You see I have done. You see the commit I have done before with I did the wrong functionality, and Professor Jose have authorized the merging. But this is something that we don't want. And then, in order to fix this, we don't fix it. Also, don't fix it in the main branch. We go back to a separate branch. I'm going to reuse the Zhou function 1, and I'll merge the main branch back in because I'm back in time. Professor Jose had did something more other than my commit, so I will have to merge the to merge his merge back into my branch and continue my development. So this is a wrong function. I don't want that. What do? I'll just revert this commit. Right click and revert. So it's reverted. When I go back inside of the same file, you can see that it is gone. It was here. So I will write it inside of the right section, the correct section. So the right functionality. Please note that I am supposed, let's say theoretically, I am supposed to write it in a small letter, R, but instead I wrote it in a big letter. This might raise problem in the future, but I didn't notice. I saved it, and I will review the change, do a commit, write function. I do the commit again, publish it to the online, create a code review again, and make the base branch as VHTL review, create the pull request. Now, Professor Jose, could you please do the code review again for me? But this time, please check the changes. As you can see, when we are inside of here, we have removed the previous wrong function and added the right function with a big letter. What Professor Jose is doing right now is by clicking this plus button, we can add a comment. You can add a single comment, or you can just start a review, and this will allow us to choose between multiple options. Is the review finished? As you can see here, Professor Jose says, please use lowercase r, thanks. I'll say, oh, right, I have to use lowercase. So I go back into the code, change, save, and commit. Now, this is an example of bad commit. Usually, I should have a reference to the task number for the traceability, but here I don't have a traceability of the task number. And in the future, when I want to go back in time to take a review of what I've done, I'll have to spend more effort, pay more effort onto finding what task this commit is about. I'll push this to origin anyway. And Professor Jose, I will give you a message saying done. Now Professor Jose will take a look at the code again. As you can see, it's shown as changed right here. So I will assume that the professor have approved my code review. Well, before we merge this back into our main branch, I would like to show you something else. So as I have mentioned before, we have file changed here to review all the files that have changed and also the conversation history. Of course, you can reply and add more comment on somewhere else. Let's say I recommend change here. I can recommend change here and start a review and yeah, so and finish review. Then it will give me some options of if I want to have a simple comment or approve the pull request or the request for changes. That is what Professor Jose has been doing, but I don't want to do that, or actually, never mind. And also, we can see the commit history of this branch. You can go back in time and see whatever commit you want. Now, Professor Jose, could you please merge the pull request? Thank you. So after a while, you can see this pull request is merged. And when I go back into the code of our main branch, you can see inside of commit history, it has been merged. And when I take a look at the code that I have done, or let's say commit, take a look at the code that I have done, you can see the changes on each commit is available. So this is the beginner version of the code management with GitHub. There are more advanced method available. For instance, you can use command line for this. You can see the changes, and you can use command like git checkout vhdl review. It will switch between the branches, etc., etc. These are more advanced method, and there are lots of techniques available for better management of your code. But I'm not gonna go into detail here. If you are interested, you can go online or simply ask me about it. And also, GitHub can also be used for code sharing. I'm sure at some point when you want a application, you go online and you find out this code is laying in GitHub. And also you can share the code as we are already doing right now, sharing the code on GitHub and taking a review of each other's code, and download it, potentially do a compiling to learn more. That's something we're already doing. So thank you for today, and for the viewers online, thank you for watching this video. Now I would like to have the class having a practice of GitHub. The stream ends now. Thank you.